I promise you a little quick demonstration. I figure it's probably going to take me a few more steps than I wanted to, but I wanted to show you basically how you can deflect your bridges without having to do a lot of whole extra work. So for the purposes of this demonstration, I have this layout and I made up some finish grade right here. So this isn't real. This is just a little demonstration. Mind you that this may or may not be the grade. And what I've done basically is a centerline grade that has a 2%, 2% each way. So for the purposes of this demonstration, I'm just going to go ahead and do one bridge because it actually follows that you do the other ones. So let's get started. So if I regen here, I'm going to get rid of my rip prep below if I can. So layer set 0 and freeze this one maybe. There you go. So basically what we have is these center lines represent your beams, and these are where they're going to be sitting, and there's already a surface associated with this. So what I did is a basic corridor that when if I turn it over, uh, again, this isn't necessarily the best bridge you can come up with, but this is just a sample. So basically what I did is a 2%, 2% each way. This is center line and 2%, 2%. And I made sure that I overextended the limits of that because you know better than anybody else that when you do your installs, you need more surface and less. So anyway, so that's the surface. So I want to know basically where these beams are sitting in respect to that surface now. So I'm going to go ahead and do a 6-inch offset from here inside. And I'm going to repeat the process here. I'm going to do outside here. And again, you want to do outside because when you go and stake out the beam, that beam is not going to necessarily sit in this way. You need the whole surface, not just a little surface. So with this line now, actually with this line, these two insides, I want to trim. In fact, I'm just going to isolate. I'm going to isolate this and this. So with these two inside now, that inside and that inside, I'm going to trim these because those more or less represent the beams. Again, I'm only doing it that one bridge because I don't want to bore you with a bunch of repetitive tasks. So the same goes here. So if we turn this on, if we trim with these, and we trim, there you go. And then the last, I can trim it to that end. Again, this is just regular American drafting. So what I want to do is I want to see how those beams fall on my finish grade up on top. So if you follow me, I'm just going to create a line here and extend it over because I later want to trim it with that one. Trim with that. There you go. So what I want to do is now I have 1, 2, 3, 4. I've got 8 beams and 1, 2, 3 spans, 4 bends, and all the good stuff. So what I want to do now, yeah, that's good. I probably need to get the better line because this is a good line. So I'm gonna back up on that, and that's a good line, and that's a good line. So what's going on here? So that's a good line, and that's a good line. Okay, and the opposite end, that's a good line. Oh, I see a mistake right here. All right, that one with that one, that and that. Okay, yeah, it's cool. It's all good. What am I missing here? Oh, that's center line. That and that, that and that. All right. Sorry about that. I did the wrong offset. That's what happened. I have an extra offset that doesn't belong there. Yeah, this offset doesn't belong there. Okay, that was throwing me off. So, in essence, there you go. I'm going to just extend. That more or less represents your beams. And just notice that I extended the center point of the beam, the connection point, 5 inches, 6 inches each way, because I want to have more surface and less. So what we do now is, based on my surface, I want to see how these lines relate to my surface. So I'm going to come up with these and make surface. I'm going to do future lines from that, and I'm going to assign elevations. I won't delete that. And for now, I'll go to the next step. And instead of using the AG, I'm going to do that. So what happens is that now I have lines. Let me turn this off. Of my beams that fully represent where the girders are. So if you remember your concepts, these are the beams, what they would look like if they were just touching the finished grade. Based on this, there's a direct offset, vertical offset between the finished grade at the top of the bridge to what it actually entails, where they sit right at the bends and the bearing seats. So for the purpose of this video, I'm just gonna argue, and let me just give you some exaggeration on this. Those are my beams right there. That's my finished grade. And notice that for every single line, for every stride, there's my 3 bends. So for the purpose of this demonstration, I'm just going to claim that they gave you at the middle at a span of 40 feet, roughly 40 feet. Let me see what this is. Yeah, this is roughly 40 feet, and this is roughly 30. So a 30-foot span and a 40-foot span bridge doesn't deflect much. So we're just going to use half an inch and an inch for the middle one, and we're going to only use, I'll tell you what, we're going to use 2 inches here, and the midpoint 1 inch, 1 inch, and we're going to use 1 inch here and half an inch. Again, these are not values that I would normally come up with. Those are values given by the engineer, and there's a lot of things that go with actually calculating those values. I just want to show you the purpose of this video is to show you what it entails to come up with the deflected bridge. So if I divide my future line into 4, and then I'm going to change my dynamic point type to that so I can see them. There you go. I'm going to divide that again to 4, that to 4, and then one more. Now that's the center line of the bridge. Now this is something that needs to happen on a special case. So if I do a model here, the minute I step outside the beam, then I'm missing something. So what I'm going to do here is I'm going to create another line at the edge and another line at the edge just to have enough surface to walk around. Not that you need it, but just for the purposes of the demonstration, when you set this beam here, it's wider than that line. So when you set the panel on that beam, it requires some meat so you can walk around it. So for that purpose, I'm going to extend that line to here. I'll tell you what, I'm just going to do another line right here to right here, and then another line at the edge. And then I'm going to isolate that line. And that one, of course, and that one, of course. So there's the line that I made. Again, this is not a beam. This is just a line to keep a surface going. So if I extend that, and if I extend this, and then I trim it here, extend it there, and trim it in the middle, trim it in the middle, extend it here, extend that, that, and trim it there. So again, this isn't something that represents a beam because you don't have a beam. You just want to be able to have enough surface to walk along and without having to lose a finish rate. So for that same purpose, I'm going to also come up with this feature lines. Actually, not like that, but feature line from objects. And I should have 1, 2, 3, 4, 5, and last 6. And I'm going to project them to the existing elevations. I don't want to well, I do want to get rid of these because those don't represent beams, but then I want to put in points in between. There you go. So when I turn this over, and if I turn everything on, that's my outside line. So I also going to divide this. I'm going to turn this off. Turn this off. So I'm going to divide these two by 4. And again, I'm assuming that that's what they give you. The actual loadings could be different. 3, no, by 4. 2 more. So here's the whole enchilada. So if you look at this, that represents how the finish rate of the bridge should curve based on the information of the PGI. I mean the PGL. So what we're going to do simply is come up with a line on the middle, right there. And notice I have my ortho. And for these short spans, I'm going to just go 1 inch, which is, undo that, 1 over 12. That's a whole lot. I don't think bridges deflect that much, but again, don't believe me. This is just an arbitrary number. I'm just I'm just trying to accentuate the deflection. And for spans that small, they don't ever. I've never seen a bridge that that deflects that much. But may or may not. I don't know. Those are not values that I calculate or I have ever calculated. So that's right there. I have an extra line right there. And then for the quarter points, we're just going to go, again, I'm just making an arbitrary number here, zero 0.5. Actually, not 0.5 feet, but 0.5 of an inch, which would be 0.04. And then I'm going to copy that value to their respective places. Now, since this is quarter points, you also do that on both sides of the quarter points. One more here, one more here. So I'm going to copy those same values, assuming that that's the same deflection on my quarter points here. Notice that the midpoint is the longest, and then I'm going to keep going here. That one, that one, that one, here, just the quarter points. And we said that the middle deflection on this is 1 inch. So we go to this and 1 inch. All right. So on the bigger span, I'm going to do 2 inches. So I'm going to go 2 divided by 12. And I'm going to copy that accordingly. Oops, not that there. We have an extra that I gotta get rid of. And then quarter point. Again, I'm making this up. I'm gonna go 1.5 inches. Could be 1.5 inches divided by 12. Oops, too much. 1.5 inches divided by 12. And again, I'm not making a statement about what the deflections are. I'm just putting arbitrary numbers just to show you how you come up with a quick model. So that's quarter point on the north side and quarter point on the south of the span. There you go. So here comes the magic. If I make a spline between here and these endpoints now, And for that purpose, I'm going to come up with a layer, and I'm going to put a color number 2 just so you can see it. So if I generate a spline from endpoints here, now what I have, look at this beautiful thing. What I have is a deflected bridge that meets the criteria. Now again, those values, I'm making them up. I don't know them. I'm just giving you a sample. So look what's gonna happen. Spline that from endpoint to that, quarter point, same over here, quarter point, midpoint, quarter point, midpoint. Quarter point, midpoint, quarter point, midpoint. Oops, something happened here. Something funny. Oh, I didn't hit it. Look at that. There you go. So, as you can see here, I have a deflected beam according to the values of the engineer slash estimator, or whoever, whoever calculates those values. Sometimes they're, sometimes they're pretty close to the plan. So we go here to quarter point. And I'm trying to make this as fast as possible so I don't lose you. Endpoint. This method was pretty useful for me because I didn't have to, once we set the beams, I didn't have to compare my values to a data, to a table. All I had to do is walk around the beams and, and get a direct reading to fill up a table. And I don't know how you divide your panels or how you divide your beams to set the panels, but sometimes you would divide the beams before they set them, and then people would set them backwards, or not backwards, but one end different than the other, and then you have to revise your table. With this, all you got to do is walk around the beams and get a direct reading on this. Granted, this deflection is not going to work once you set the panels because by definition you would have added some weight to it, and there's a way to come up with another one, but then you get to the you get to a point where you really have to calculate a new deflection based on the weight of the panels, and you may not want to do that. I mean, this is just the initial good one. So, okay, and almost to the end here. So there's my defective beam, I mean bridge. So what we're gonna do now, based on the new layer, I'm gonna just come up with a line. Actually, I don't even have to come up with a line. I already have that line. All I gotta do, well, I'll tell you what, I'll just come up with it. I can just go here to endpoints. Two more bends. Actually, an abutment more and two bends. Mm. Now, one of the things that also happens here is that independently as to how your bearing seats sit at the bottom, your bend is always not gonna deflect. So I don't really care if there is a different size of beams. What matters is that when you set the panels, there's going to be no deflection there, and there's going to be some deflection in quarter points, and there's going to be the greatest deflection at midpoint. So this is a method that you don't have to really think about the beam difference between one end of the abutment or bent to the next, because ultimately the panels have to sort of line up. Now you may run into different sizes of thickness and panels. You may not, but the idea still pretty much remains the same. Um, and I'm almost a few lines from finishing here. And last one here. Uh, be have in mind that this is also on the other side. But anyway, so that's pretty much the premise. So all I got to do now is turn this off, and then divide these. Now the division on these is going to be more than that. So this is a 30-foot span. So I'm gonna do 30, 30 for each one of these 30s. And then this is a 40 span, so I'm gonna divide this by 40. Oh, not 4, but 40. And then last 30 again. Okay, so last thing, create a new surface, call it deflected FG. And for the items on this deflected FG, I'm just going to call out, I'm going to isolate this layer first. I don't want to pick up anything else. So on deflected, under definition of break lines, add, and I'm going to just grab everything like that. And then drawing objects, add points, and boom. So I look at my surface properties. I've got contours, but they're probably not on the model. Okay, yeah, they're on. So deflected. Oh, I have to turn everything on. Dummy. Layer on everything. Layer on everything. And look at that. So for the purpose of you seeing the deflection, which I'm sure you did see it, let's just isolate that. We're gonna do something to the surface just so you can see it. Under the surface properties, actually under this, we're gonna go on the design, and we're gonna put some exaggeration on that so you'd see it. Under contours, no contours, points. No, that's actually here. Exaggerate, and I'm gonna just exaggerate it by 10. Now it doesn't mean that that's the surface, it's just exaggerated, so you see what happens. Now let's just turn this one off to no display because that's the original. And voila, let me change the color on that. Let's just put a better color on that. Display, how about one of them? So there's your deflected bridge. So the beauty of this, again, is that you set your beams, and you want to see how much panel, I mean, how you're going to cut the panels, not the panels, but the foam for the panels. Now, anywhere you walk around that beam, you're going to get the right amount of foam if you add, actually, if you lower it enough to account for the deck thickness and panel thickness and all of that good stuff. I hope it helps. Um, and if you enjoyed this video, thanks for watching. I hope I meet you again. Thank you.